Hello, Shreyas. Hi, good afternoon. So we are waiting for all other students to join today. So, yep, I need the okay, cool. So let's wait for some time so that all students will join. So once many of you have joined, we'll start with our class. So in today's class, we'll be discussing about the concepts which we had. Yes, good afternoon, Shreyas. Yes. So in today's class, we'll be discussing about the effects of dielectrics on capacitor, and we'll complete that. Then we'll talk about the breakdown of dielectrics, and we'll solve some problems, and that would be the end of this chapter. So, so actually, we are in the end of the chapter. We were supposed to complete it on Saturday itself, or before Saturday or Friday by then, but maybe due to maybe because of my sickness or some lag happened, and we were dragging this chapter till here. I think we will complete this today and start with current electricity by tomorrow. So we'll check that. So I'm launching you the technical check poll, guys. Everyone, please take the technical check. Let me know if my voice is audible clearly and if the screen is visible clearly. So good afternoon, guys. Good afternoon, Pradeep, Shreyas. So guys, is there any test for you guys scheduled on next few days in this week? So this is one important data I require. So there was some discussions about test WhatsApp group where other students were posting. Yeah, I want to know about the same. Is it the same thing which is scheduled with you guys too? Please let me know about the tests if you have any. Okay. So good afternoon. Who else is here? So we have Tejas. Hi Tejas. Suharsh. Sorry, Suhas. Suhas Arji. Hi. Good afternoon, guys. So guys, so Tejas in Mysore is the test scheduled. And what about the YouTubers, guys? Do you have any unit test scheduled in your school? Yes. So yes, it's time for us to start the class. So actually, I see very less number of students right now. So waiting for more students to arrive in Zoom and also in YouTube. So okay, you have test from third. Cool. So most of you have test from third. That's what I learned from the school principal whom I'm in touch with. So okay. So is it the same time when all the schools would get the test? Okay, cool. Yes, Suhas will start. Um, okay, guys. So I'm going to end the technical check for you guys. So again, please let me know if at any time if my voice is not audible or if my blackboard is not visible at any time. Please let me know. Okay, let me know in the chat box. So I'm going to end the poll now. So let's start with the chapter. So now, what did we study in the previous class? So we studied about dielectrics, effects of dielectrics in a capacitor. If I'm not wrong. So what we thought we studied about, say a capacitor. Say if we consider a parallel plate capacitor. So I had two plates of a capacitor. Now this plates of a capacitor is connected to a battery. So what happened when I connected this to a battery? So I had connected this to a battery of potential V. So what happened? There was positive charges formed on one surface and negative charges formed on the other surface. And in the inner surface, what happened? So in the inner surface, there was a formation of negative charge, net negative charge induced, and on the other surface, there was net positive charge induced, and there existed an electric field in this direction, right? So this is what had happened inside a capacitor. Now what happened, I introduced a dielectric to it. So I introduced a dielectric medium of dielectric constant. So of dielectric constant K. What happened now when I introduced the dielectric? So this assume this is a non-polar dielectric. So what happened inside the dielectric? Inside the dielectric, what happened? So if this is the dielectric medium, what happened inside the dielectric medium? Reply, guys. What happened inside the dielectric medium? So there was positive, there was electric field in this direction, right? The electric field was in this direction due to the plates of the capacitor. In the plates of capacitor, my electric field was in this direction. So what happened inside the electric? Yes, there were formation of dipoles. So there was formation of dipoles where all positive charges were formed on one end. Say all positive charges were formed on this end, all negative charges were formed on this end of the dielectric medium. So I'll try to draw here. I don't know if it's visible. Okay, so each dipoles had a dipole moment of small p. The net dipole moment was along this direction, and it was in the same direction as that of electric field, right? So what happened in the when okay, yeah, the dielectric gets polarized. So yes, we assume such dielectric. So where are these polarized charges formed? So guys, I will represent these polarized charges with just positive, since these are formed only on the boundaries. Since these are formed only on the boundaries, I just represent them with the boundary condition. Okay, okay, I have just represented them in the boundary condition. Now I'll draw the plates of the capacitor also. I'll draw the plates of capacitor. Say my capacitor plates initially were having certain charge in this way. Okay, now 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 had removed the battery. In first case we studied about, we have removed the battery. What happened to the charges present inside the capacitor? So the capacitor, inside the capacitor there were some charges present still. Inherently there were some charges present still between the plates of the capacitor. So whatever the charges battery type, I mean, if we had connected positive here, there was negative surface charge density formed in the inner surface of capacitor, and opposite polarity was induced inside the dielectric medium. So what happened? So there were induced dielectric capacitance in the dielectric medium. Okay, so there were some charges. Now these charges combined with this dielectric medium, right? These charges, when the plates combined with the dielectric medium, what happened to the potential on the capacitor plates? So what happened to the potential on the capacitor plates? The potential on the capacitor plates reduced. Yes, so the initial capacitance was known as C is equals to epsilon naught A by D, and we know C is equals to Q by V. Now this capacitance changed itself to K times of epsilon naught A by D. Then we saw that when the potential decreases, the capacitor increases how many times? K times. So the capacitance increased by the dielectric constant times in this case. Then we had checked for the situation where we had uh, checked the effective capacitance. Then we had checked for the condition what happens to the capacitance, the electric field or the electric charge. So for in the case of electric charge, my charge on the plates remains same. So in the case of no battery connected, when no battery is connected, the charge on the plates remain the same. The initial charge was Q naught is equal to C naught V naught, and the final charge is still the same, but not the capacitance. Okay, why is it same, guys? So we know that Q final, then Q final will be also CF VF, right? CF, I mean final capacitance into final potential. So, but still my QF is equals to Q naught. How? How do you think my final charge is still the same? If QF is equal to CF into VF. See, my CF is increasing by a factor of K, but still my QF is constant or same when in the uncharged condition where my battery is not there. Yes, yes, Hari Prasad. We had introduced the dielectric to increase the capacitance. Yes, guys. So what's happening here? Though my capacitance is increasing by a factor of k, and simultaneously my voltage or potential is reducing by a factor of k. So it's annihilating. The k factor is getting destroyed. So I'll be having the same amount of charges. Yes. Then we know that electric field is reduced by a factor of k when the dielectric medium was introduced. And we also discussed about how the potential decreases by a magnitude of k. So here, that's what was happening. When my capacitance increased with the factor of k, my potential reduced with the factor of k. So these k got cancelled. Then the initial charge was equals to final charge. Hope this is understood by everyone. Next, we discussed about the energy stored in the capacitor, that is Q square by half C. Sorry, it was given by initial energy was given by Q naught square by 2 C naught square, where Q naught and C naught are the initial capacitance and initial. Okay, these were the initial capacitance and initial charge stored. So what happened to the final charge? The final energy stored in the capacitor reduced by a factor of k. Right, since my capacitance, so we know q u energy stored in capacitor is given by q square by 2c. Now my q square remain the same. Since my q naught is equals to q, my q remain the same, but my capacitance c naught in the final condition changed as k times of c. On substituting, we get that the final energy stored in the capacitor without battery connection, the energy stored is reduced by a factor of k. Okay, this we had studied so far. Okay, next in today's class we'll study about. Yep. So any doubts in these, guys? Till here, any doubts? Please let me know. Any doubts still here? So we had compared both the condition, initial condition and final conditions. Any doubts in this? Okay, no doubts. Others, please reply or let me know if you have any doubts. Okay. Next, in today's class, we'll be discussing about what happens to the capacitance of the capacitor in case, okay, in case if we connect a battery. Now, when we connected a battery, so with battery, we'll check with battery. So initially what happened, we connected a battery. My outer plates of the capacitor, say in the left hand side, this plate got charged with positive charges. Then this induced a negative charge in the inner plate with magnitude of minus QP. Then this negative side of the battery charge the right hand plate with outermost plate with minus q charge. Then this negative charges induced a positive charge of magnitude plus qp, where qp stands the plates charges induced on the plates. Okay, now there existed an electric field between the plates of magnitude e. Now what happens? So the capacitance is given by, here in this case without dielectric medium, the capacitor is given by C is equals to epsilon naught A by D. Now what happens? The charge on the plates and the potential. So the charge on the plates of capacitor is Q and the potential is V. Then now if we don't remove the battery, and remember this, now we are not going to remove the battery, but are introducing the dielectric medium. So I don't remove the battery now. So I have introduced the dielectric medium. I will not remove the battery, but I have introduced the dielectric medium. What happens now? This is very important, guys. What happens now? So now introducing the dielectric medium, instantly what should happen? You guys should say, ಏನಾಗಬೇಕು battery. Okay, in this condition I have battery, yes, but I have introduced the dielectric medium between the plates. Okay, so still there exists an electric field between the plates in this direction. Okay, there exists an electric field between the plates of the capacitor in this direction. Now I have introduced the dielectric medium. What will happen? Yes, correct. Okay. Polarization of dielectric medium or dipoles formation in the dielectric medium happens. So there exists a dipole moment between each of these. There exists a small dipole moment in each of these dipoles formed inside the dielectric medium. The net dipole moment will be along this direction, same as that of electric field. So my P net will be along this direction, same as that of electric field, which is also in the same direction. Now, so my now the electric field, what happens? Initially we had studied that the electric field reduces, right? When dipole is formed in the presence of battery, when dipole is formed, what happens? My electric field reduces. How? Why does my electric field reduce? See, listen. What happens? This charge and this positive and this negative charges combine with each other, and what can we say? This cancels out. So these two cancel out. Okay, these two cancel out. Then what can we say about this? All the positive charges which were on the plates, yes, always from negative to positive, right? See, my dipole moment is from minus charge to positive charge, Hari Prasad. And here my electric field also is in the same direction. We had discussed this in our previous class. Please refer previous class again. Okay. Yeah. So what's happening here in this case, guys? Again, all my positive charges and negative charges due to the surface charge density, negative surface charge density minus sigma p is getting cancelled, right? Similarly, here also the positive charges and negative charges, the positive charges due to positive sigma p, surface charge density, positive sigma p, and some negative charges in the plates of capacitor. What's happening? They combine, or what they cancel out. Or what can we say about this? All my negative charges are just entering the dipole. So I can also say that as my negative charges are entering the dielectric medium. Here, similarly, my positive charges are entering the dielectric medium and are being stored inside the dielectric medium. Now, what happens? What should happen generally now? What should happen generally now? What should happen to the potential when the net charges on the plates decreases? What should happen to the potential? Guys, are you following? Yes. So obviously my potential between the plates reduce. So, but what's the condition we are talking about? We are not not removing the battery. Okay, we are not removing the battery in this condition. So we are not removing the battery in this condition. What will happen now? Yes, my potential will obviously reduce, but we have not removed the battery in this condition. In previous condition we had removed the battery, but in this condition we have not removed the battery. What should happen? Though, yes, on the plates of the capacitor, initial condition at one moment, yes, the potential reduces. But what happens? What is the work of battery? What is the work of battery here? Guys, what do you think the work of battery is? See, the work of battery is to provide enough potential, right? To maintain the potential. So battery, so what is the use of battery? Battery maintains the potential here. Okay. Why am I right? So yes, battery maintains potential. So what should happen? All these cancelled charges, my battery, it will generate more negative charges to this plates. It will give out more negative charges to this place. This negative charges, whatever the negative charges here, this negative charges will induce more positive charges inside the plates. Okay. These negative charges will induce more positive charges inside the plates. Similarly, here more positive charges are being dumped. Okay, so these positive charges will induce more negative charge. I mean, negative charges inside the plate. Now, what happens? The potential remains constant. Yes, the potential remains constant on the plates of the capacitor. Correct. So my potential does not change when my battery is connected. So there is formation of wound charges, but there is no change in potential. So there is no change in potential. And what happens if there is no change in potential? What happens to the electric field, guys? Electric field, wow, what will be the effect on electric field? Electric field also remains constant. So with capacitance K and the potential connected, since the battery is connected, the potential will not reduce, the charge on the plates increases. Now what happens? So further, so these charges are cancelled out, right? So these charges were cancelled out, but further, because of battery, more amount of charges were pumped to the capacitor plates. More amount of batteries were given to the capacitor plates. So what happened to the final charge stored in the battery? So more amount of charges were given to these plates, right? What happens to the number of charges on the plates? What happened to the number of charges in the plates? Is it remaining constant, increases, decreases? What's happening here? What happens to the number of charges, Q? So if initially Q amount of charges were pumped or pushed to the plates of the capacitor, now what happens to the charge? Yes, correct, Hariprasad. So the charges on the plates increases by a factor of K. So the charges increases by a factor of K. Now the final charge stored on the plates of capacitor is K times of Q. Okay, in the entire capacitor, the final charge stored is K times of Q. Obviously, from using the equation C is equal to Q by V, my V is remaining constant, but my Q increases by a factor of K. So what happened to the capacitance? Final capacitance obviously will increase. So the final capacitance is given by CF is equals to K times of CI. So this is how my capacitance increases in case of a battery, in case when a dielectric is introduced with connection of battery. Okay, I hope everyone have understood this. Any doubts in this? Guys, let me know if you have any doubts. So in previous case, what was happening? There was no battery here. So all my charges went inside, my potential decreased. But here in this case, my potential remains constant because my battery provides the enough potential. Okay, again. So listen guys. So what is happening in previous case? Yes. Yeah, we'll compare that. Next we'll compare. Okay, Pradeep. So this is understood, right? At least till here it is understood, right? Yes. Cool. Now we'll compare how it is for initial condition and final condition. So initially my capacitance was how much? C is equals to epsilon naught A by D. And final condition after introducing the dielectric, what happened? So we know that C is equals to Q by V. We know that C is equals to Q by V. In previous case without the battery, here with battery, okay? With battery. Note that both the condition we are talking with battery connected. With the battery connected. So what should happen? So in previous case, without battery condition, my potential was reducing, but in this case, the capacitance increases because of increase in the charge. So what's happening? My charge is increasing. How much is my charge increasing? My charge is increasing by a value of K times of Q. So my Q final is nothing but K times of Q initial. Okay. So this way my capacitance increases. So the final capacitance in this condition is K times of epsilon naught A by D. So initial capacitance was C naught, that is epsilon naught A by D. Final capacitance after introducing dielectrics will be K times of epsilon naught A by D. So next conditions. So the initial charge stored on the plates of the capacitor is given by Q naught is equal to C naught V naught. The final charge stored on the plates, only on the plates guys, or in the entire capacitor, we can also consider on the plates as well as entire capacitor. The final charge stored on the capacitor is given by K times of Q naught. Okay, so initially was stored with Q naught charge. After introducing dielectric, what happens? So there was formation of charge. So I'll just brief it out. So after after introducing the dielectrics, there was polarization in the dielectric medium and few charges from, okay, so whatever I'm writing here are the boundary charges only in the inner surface. Okay, okay, why confusion? I'll write here like this only. So because there was one confusion among one of the students because of this, please note that, guys, don't get confused. So I'm just writing the boundary conditions here, only boundary conditions, I mean boundary charges here. So what was happening? So there were many n number of charges on the plates. So some charges combined with the plates, I mean combined with the dielectric medium charges, and they got annihilated, and more charges were pumped from the battery to the plates of the capacitor. So the capacitor increased, I mean the charge on the capacitor increased by a value of K. Okay, that's what. Then what happened to the electric field? Initially, my electric field was given by E naught is equal to sigma by epsilon naught. So on introducing the dielectric medium, what happens? So the electric field, final electric field will be same as the initial electric field. So there won't be any increase or decrease in the there won't be any change in the electric field. Why? Why is there no change in electric field, guys? So if you guess, if you see initially, there was reduction in electric field, right? Yes, there was initially in previous case. In the previous case, without connection of battery, there was reduction in potential. Okay, but in this case, there is no reduction in potential because of battery, because the battery pumped the enough charges, and those amount of charges maintains the electric potential and the electric field also. Next, the potential VF also remains the same. Initially, the potential changed by, or in the previous case, without the battery condition, the potential had reduced by a factor of K, but in this case, the potential remains same as that of previous. Okay. So I hope this is understood, guys. If you want elaboration, I'll, okay, listen. So what was happening in previous case? We know E is equals to sigma by epsilon naught, right? So when I introduced the dielectric medium, what happened to this electric field? So when I introduced a dielectric medium, so what happened, guys? So tell me, without the battery condition, when I had my electric field without the battery condition, what happened? So if you remember, guys, we discussed this. My net electric field is less than that of E external. Do you remember this? Magnitude of net electric field is less than E external. When we tried to check what was the magnitude of E net, we got E net is somewhere around 1 by K times of E external. If you remember, guys, you remember this? E net reduces by a factor of 1 by K. Hope this is remembered. Zoom people, please reply. So without battery connection, my net electric field reduced by a factor of K. Now what happened with battery? When in the presence of battery, the enough amount of charges were pumped. Why? We know E is equals to sigma by epsilon naught, right? So if I try to write this in terms, I'll get Q into A by epsilon naught. If you remember, sorry, Q by A into epsilon naught. Since sigma is equals to Q by A, if I substitute the value of sigma as Q by A, then I'll get my E as Q by A epsilon naught. Okay. So since here my E reduced by a factor of K, what was happening to Q final? If I put the value of Q final here, my final value of Q increased by a factor of K times of Q naught, and since my E final was reducing by a factor of K, so this was happening. Okay, so the K, the denominator and numerator got cancelled. Finally my electric field was as initial. My electric field was similar to that of initial electric field only. Hope this is understood, guys. If anyone requires repetition, I can repeat that again. Please let me know if you want. If you are still confused, yes, or let me know if you have got this. Guys, please, I request everyone to revise if you have any doubts in the previous class. Zoom people, please reply. I need a reply from you guys, either verbal or non-verbal. Bhargav will discuss about resistance in next chapter, no? So we don't want to introduce resistance here. We'll discuss about resistance in resistance chapter. Okay. ಓಕೆ, ಅರ್ಥ ಆಗಿದ್ಯಾ ಹೆಂಗ್ ಬಂತು ಈ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯಾಕೆ ಸೇಮ್ ಇರುತ್ತೆ ಅಂತ ಅರ್ಥ ಆಗಿದ್ಯಾ? ಓಕೆ ಗೈಸ್, ಕೂಲ್, ಥ್ಯಾಂಕ್ ಯು. So next, since okay, again, we know that V is equals to E dot dr. From here, if my electric field, final electric field is not reducing by a factor of k, even the potential will not reduce by a factor of k. Potential remains constant. The potential also remains constant. Next, what happens? The energy stored in the capacitor. If we know energy stored in capacitor is given by U is equals to half CV square, then the energy stored in final condition, what will happen? So we know that the final capacitance is given by CF is equals to K times of C naught. So on substituting here with CF as K times of C naught, we would get energy stored as U is equals to half K times of C naught V naught square. So on substituting this, if you try to see, this is my C naught into V naught. If U is equals to half C naught V naught square, then the only factor which it's multiplied with is the factor K. So what can I say about the final energy stored? The final energy stored inside the capacitor on introducing the dielectric is K times of initial electric energy stored. So the final energy stored in the capacitor is K times of initial energy stored in the capacitor. Okay, so U also increases by a factor of K as my capacitance increases by a value of K. Okay, not U Hari Prasad, not potential, it's the capacitance which is increasing by a factor of K. Okay. Okay, guys. So this is the comparison between the initial and final condition with battery connected. So in previous case, we discussed about without battery connected, how my capacitance and all other factors varied. In this case, in this slide, we were discussing about how my capacitance increases when my dielectrics is introduced in the presence of battery. Okay, in both cases, my capacitance increased. Understood, guys? Any doubts, please let me know. Or if you want any repetitions of any of the concepts, let me know. Hope this is clear at all. Everyone, please click on yes if you have got this. Or if you have any doubts in any part, please let me know. Others, please try to respond. So we have a breakdown of dielectrics. Once we are done with breakdown of dielectrics, we can start with next concept, guys. We can complete this chapter soon today. Don't want to drag this. Please help me finish. Okay, guys. Thank you. Cool. So next we have parallel plate capacitors. So multiple dielectrics. So what? How can we solve the effects of, or how can we solve if we have multiple dielectrics introduced in between a parallel plate capacitor? So let us consider the two plates of a parallel plate capacitor. So we have two plates connected in this fashion. Now we have introduced two dielectric mediums of dielectric constant K1 and K2. So now we have two dielectric mediums K1 and K2 introduced between the two plates of this parallel plate capacitor. So these two have the same area of cross section A. Guys, please listen. Again, these two dielectric mediums have the same area of cross section A, but their length of dielectric. So if I have to show these in 3D, so I can show something like this. So these have the same cross-sectional area. So this is my area, but their length or thickness is d by 2. half that of the separation between the two plates. Okay, so we have two plates of capacitor, right? In between them we have a separation distance of d, so exactly half of this separation length, so that is d by 2 length, we have two capacitors of, sorry, two dielectric mediums of k1 and k2 introduced of thickness d by 2 length, and area of cross section is a. Now what happens to the capacitance? So we know the capacitance of the capacitor is then can be calculated as two capacitors. So if we get such problems where we have two dielectrics introduced between the plates of capacitor, we have to directly take it as two capacitors, assuming that there exists a metal plate. So assume there exists a metal plate here, this between these two. Now these two becomes more like two capacitors in series. Okay, these two become more like two capacitors connected in series C1 and C2 across the same potential V. Okay, now we have learned about how to calculate the capacitance of capacitors connected in series. So that is given by 1 by C effective is equals to 1 by C1 plus 1 by C2. So what is the value of C1, guys, from here? Can anyone help me? We'll come to that discussion, Hari Prasad. First, let us solve this. Okay, we will come to that case. That's the next case. If area is different, that is next case. We'll come to that. So we'll solve all cases. Okay, please wait. So yeah, here we have, yeah, guys, come on, tell me what is the value of my capacitance C1. Say if I assume this dielectric medium has a capacitance, say by assuming a plate here, I say this is capacitor C1 and this is capacitor C2. Now what is the value of this capacitor C1 in terms of yeah, I need the answer in terms of your capacitor, parallel plate capacitor expression. Yes, Madhavi. So, yes, Madhavi, that is correct, but I need in terms of parallel plate capacitor equation. Okay, so we can write that capacitance as C1 is equals to K1 times. So K1 is the dielectric medium constant or dielectric constant of this dielectric medium K or K1 times epsilon naught. Since my area of cross section is A and the thickness or the length between the two plates. So if I'm assuming this is one plate, this is second plate, then the thickness of between these two plates is d by 2. So I have substituted the value of d by 2. So this is my expression for capacitance C1. Similarly, what will be my C2, guys? What will be the value of C2? So listen, C2 will be K2 times, similarly, C2 will be K2 times of epsilon naught A by D, where A is the cross-sectional area of this parallel plate capacitor, and D by 2 is the thickness, length of this dielectric slab. Okay, so this is the expression for C1 and C2. Now, if you substitute the value of C1 and C2 here, or if we try to calculate what would be C effective, say we know the effective capacitance of two capacitors connected in series combination would be C1 C2 divided by C1 plus C2. Guys, please take 30 seconds of time to solve and please come up with the final expression. Guys, yeah, please take some 30 seconds or 1 minute of time to solve this and come to an expression. Okay, so please try to solve that. What is the effective capacitance? So you should get this expression. You should get this expression in the final answer as the final answer. So we'll try to solve that, guys. Come on, C effective. Okay, let's solve together. Okay, so C effective we know that as C1 C2 divided by C1 plus C2. Now what is my C1? C1 was equals to K1 times epsilon naught A divided by D by 2, and C2 is nothing but K2 times epsilon naught A divided by D by 2. Now, guys, come on, plug in this value, or if you have any other simpler method, you could follow that. Okay, please try to solve this. Okay, we know C effective. From here, I'll try to write. There's nothing but K1 times of epsilon naught. So can I write epsilon naught A d by 2 as, can I write epsilon naught A d by 2 as C? I'll take this as C. Okay. Is there any difference, guys? Can I assume, or can I take epsilon naught A by D? Sorry. Can I take C is equals to epsilon naught A by D by 2? Yes, I'll take. Okay. So K1 times, this will help me simplify. Okay. This will just help me simplify my expressions, math expressions. Instead of writing a lengthy one, I can write a simpler one. Okay. Yes. Come on. Okay. Cool, Hariprasad. Super. Awesome. Yes. So K1 times C into K2 times of C divided by K1C plus K2C. So if you see here, from here, I'll get K1, K2 divided by K1 plus K2. In numerator, I'll get C into C, that is C square. In denominator, I'll get C plus C, that is C. From here, I can cancel the values, as C square by C is C. So I get my C effective as K1, K2 divided by K1 plus K2 into epsilon naught A by D by 2. Should I get this? Yes, please check with this. Check the answer, guys. Yes. So you should get some. Yep. How many of you got the right answer, guys? I hope all of you have got that. Yes, Pradeep Sikta. Somewhere you should get some answer like this. If not A, okay, 2 will cancel. Yes, I think 2 will cancel with the numerator 2 and denominator 2. Somewhere, yes. So you should get end up on simplifying. You should end up with this answer: K1 K2 by K1 plus K2 into epsilon naught A by D. Okay. So somewhere here, if you substitute the value of C, I think I'll try to substitute the value of C. Okay. So you'll get epsilon naught square A square by D by 2 whole square by epsilon naught A by D by 2. So okay, so I should get 2 into epsilon naught A by D common. Fine. So I'll get 2 into epsilon naught A by D common. So 2 into epsilon naught A by D by 2, or okay, this I'll get divided by epsilon naught A by D, is it? Or divided by 2, something like that. Then we'll get this expression. So we'll be getting this epsilon naught A by D in your final expression. Okay, so this is just C effective. So C effective should be, yes, 2 gets cancelled. Oh, 2 gets cancelled. So you'll get K1 K2 by K1 plus K2 epsilon naught A by D as your final expression. So similarly, guys, if we have multiple dielectrics, say, yeah, that was the first case. Hope everyone got that. So similarly, if you consider two parallel plate capacitors, say if we have two plates of a capacitor separated by distance D, now, yeah, if we have two dielectric mediums of same length D but different area of cross section A by, say we have considered different area of cross section. Say first area of cross section, say if I have a dielectric medium of area of cross section A by 3 as first slab, and second dielectric medium has a construction of 2 by 3 times of A, 2 by 3 times of A. So 1/3 area is covered with one dielectric medium, and 2/3 dielectric. I mean 2/3 area where or 2/3 of the volume between the plates is filled with this dielectric medium K2. Now the effective capacitance is calculated as two capacitors connected in parallel. So it will be more like one capacitor with area A by 3 and distance D connected with a second capacitor of area A 2A by 3 and distance D connected across the same potential. Okay, if these are connected across the same potential, the effective capacitance can be then given as C1. C effective is C1 plus C2. So here my C1 is K1 times epsilon naught A by 3 by D, and C2 will be K2 times epsilon naught A by 2 A by 3 into D. On substituting the values of C1 and C2 in this case, we'll get the final expression as C effective is equals to K1 by 3 plus 2 K2 by 3 into epsilon naught A by D. Okay, so this is the general expression how we have to solve when we have multiple dielectrics introduced between the two plates of a capacitor. Hope this is understood, guys. Yes. School. So yeah, now we'll come to this concept. So I have a concept test for everyone. Please check your concept test. So I have a charged capacitor. So it's based on the concept with which we learned now. So I have a charged capacitor. It is removed from the circuit. So I have a capacitor which was connected to the circuit. Now this capacitor is removed from the circuit. Now it's separation between the plates. So first initially assume I had a capacitor. Okay, only the capacitor without dielectric medium. So initially I had a capacitor without any dielectric medium. Okay, now I had connected this to a battery. So this was charged to some potential Q and minus Q on the outer surface plus, sorry, minus QP and plus QP on the inner surface, right? So this was charged to some extent, some charges here. Now, once this is charged, I disconnected the battery. Okay, I disconnected the battery. Now, this plates, this there exists some charges inside the plates even now. So there exists some charges on the plates even now. No, should sorry. So what happens when I introduce a dielectric medium? So they are asking what's the question is. The question they are asking is, now first one half of the plate is filled with a dielectric constant K1 and the other half of the plate is filled with a dielectric of constant K2. So one part of this is filled with K1 and other part of this is filled with dielectric medium K2. Okay, let's see that case also. So I have one part filled with dielectric medium K1 and the other part is filled with dielectric medium K2. Now, see, come on guys, let me know. In the inner plates of capacitor, say if I consider this is the boundary of my K1, okay, in the inner surface of K1, see, here I had a charge of minus, right? I had negative charge on the inner plate of the capacitor. What is the charge formed in this side of the dielectric medium? What is the charge formed on the inner surface of K1 on left side? Guys, really, what is the charge on the left side of K1? Obviously, it is positive, right? So this should be positive charge. So there is formation of dipole only in K1. So what is the charge formed here? Yes. What is the charge appearing here? It's minus, right? here it should be minus on the other end, so on the boundary condition. By boundary conditions, if one end of the boundary is positive, other end should be negative. Now guys, can K1 induce charge on K2 is the question. What is the charge appearing on surface 2 of K2? So this is surface 1 of K2, this is surface 2 of K2. Okay guys, please make sure, make understand, wherever it is touching the plates of capacitor, that is surface 1. Wherever there is no plates of capacitor, the other end is surface 2. So this is surface 1 for K1, this is surface 2 for K1. Okay, this is surface 2, I mean this is surface 2 for K1, surface 1 for K1, surface 1 for K2, and surface 2 for K2. Okay, now what are they asking? What is the charge appearing on surface 2 here at this region because of K1, due to K1? What is the magnitude of, or what is the type of charge, or what is the charge appearing on surface 2 due to the K1? Is there any charge formation on 2 because of K1, not because of plates, because of K1 is the question. Okay guys, I'm quickly launching the poll. I hope everyone got the question artha agidya? Hope you guys have understood the question. See, the question is clear. These charges are inducing some dipole moment inside the dielectric medium. Now the question is, what is the charge appearing on surface 2 because of dielectric medium surface 1? So dielectric medium 1 in the dielectric medium 2 ಅಲ್ಲಿ other charges induce ಆಗುತ್ತಾ ಅನ್ನೋದು question. Hari Prasad. Okay guys, please reply your answers. Okay Bhargav, check your answer again. Bhargav, check your answer again. Madhavi, check your answer again. Guys, so I'm repeating the question. What is the charge appearing on surface 2 of K2 because of Q1 or due to Qa1? So the question will be very simple. If I try to change the question, it's like, is the charge K2, I mean, what is the charge K2 because of or due to the inducing effect of K1? What is the charge on K2 because of K1? That's the question. Okay. Hope you got the question, guys. Zoom people, please reply if you have got the question. Question ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳಿ, ಏನ್ ಕೇಳ್ತಾರೆ ಅದು ಗೊತ್ತಾಗಬೇಕು. So please reply if you have not understood the question clearly. Yes, question is understood, right? Okay guys, so it's taking more than 2 minutes, so I'm going to end the poll. So students have answered option A as your answer, but unfortunately option A is not right. Option C is the correct answer. So please go through this. So what's happening here is, yes, exactly, since the plate, say, suppose, yeah, here in the solution they have considered this as my negative plate, and this should, okay, this as my positive plate. So what happens? Okay, sorry. This has my positive, and okay, this is right. So since this is positive charge, there is formation of negative charge on the inner surface. Oda. So because of, okay, now I have removed the battery. Say, assume I have positive charges on one end. Please go through this again. Okay. And there is this dielectric medium which is getting induced with negative charge and positive charge, right? So this forms a dielectric medium like this. So there will be formation of electric dipoles in this way. Okay. Now answer this. Is my dipoles having free electrons? is my dipoles or dielectric medium has free electrons. See, only the free charges present can only induce charge on other surface. Okay. So can these free charges, I mean, is there any free charge in dielectric medium of K1 to induce the charge on dielectric medium K2? See, only the charged particles can induce, only the charges which are present on the plates can induce the dielectric medium to undergo dipole or to form dipoles. But here my K1 doesn't have any charge to induce dipole moment in K2, so it is not possible. Again, mathematically, when we check, the dipole moment in K1 is given as summation of the charges, that is given by Q1 by 2A epsilon naught, right? On one end is given by Q1 by 2A epsilon naught minus of, I mean, plus of minus Q1 by 2A epsilon naught, that is the electric field on the other end. So the net electric field because of K1 on K2 will be 0. So Hariprasad has said out, charge induced to dielectric is due to capacitor, not due to, yes, exactly, Hariprasad. That's it. So please go through this and let me know if you have any doubts. So, but do note that the charges appear on the surface of K2, but no charges appears on it due to charges on K1. Yes, there will be formation of charges on K2 too. Yes, it will be exactly plus Q1. Okay, it will be plus Q1 on K2, but but these charges plus K1 or plus K2 is only because of the capacitor plates. Okay, guys, again I have to make one note. So please be very sure, 100% sure to read the question very carefully and while taking the charges. So here I have given positive and negative charges in this way, but in some other textbook they might have given the positive and negative charges as here only. So one of the plates is charged with plus Q and other plate is charged with minus Q. At that time, what should you consider? What should you consider? Please be very careful with the questions. Okay. Sometimes they will just mention the positive charges on the plate of the capacitor, negative charges on the plate of capacitor. They simply mean the positive and negative charges are on the inner surface of the capacitor. So you have to assume this entire thing is positive. If this is positive, what will be induced on the dielectric medium? If this is positive, what will be introduced on the dielectric medium, or what will be induced on the dielectric medium? Not understood. Guys, please reply. Okay, are you getting what the question I'm asking? What is the question I'm asking? See, if they mention in question paper, sometimes they won't mention what charge is it in the inner surface. They will just say a plate which is positively charged. It means the plate is positively charged throughout. I mean, in the inner surface only. Outer surface, they won't speak about outer surface always. So if a plate is charged with positive charge, yes, it is completely charged with positive charge. So if it's connected with the battery, in some questions, they will give only this much. So it's connected with the battery. How will you approach this? Guys, please reply. Okay, so how many of you did not get this question? So I'll just talk about the question. Say what's happening here. I'm explaining again. Krishnamurti, please listen. So what's happening? Say I have two dielectric mediums on the charge plate. Say initially I have some battery connected and these plates are charged with plus and minus. So what happens? This positive charges will induce a negative charge on this surface. Okay. Similarly, here the negative charges will induce a positive charges on this surface. Okay. Assume. So I'm just assuming this. So since this is positively charged, on the boundary condition, there will be formation of opposite charges. Okay. Similarly, here also there will be formation of opposite charges. But in this question, they are asking what is the charge on the surface 2 because of my charge in surface 1. I mean dielectric medium 1. Say because of K1, what is the magnitude of charge on K2? It is not possible. Okay. Why? My K1 cannot induce any charge. My K1 cannot induce any charge on K2 because K1 itself is a dielectric medium. Krish Modi, please understand that. So my K1 itself is a dielectric medium. It cannot induce charge on K2. Only the capacitor plate 2 can induce charge on K2, but not the dielectric medium 1. Understood? Please give confirmation, guys, if you have understood. Please give confirmation, guys, so that I can go to next question. Please let me know if you have understood. Yes, Pradeep, ask it out. Pradeep, if you have any doubt, please ask. Okay. Okay. Cool. Krish, I need. Yes, exactly, Krish. That's the answer. So the charges induced on K2 is only because of plates of capacitor, not because of the dielectric medium. That is what the final answer is, guys. Okay, please, guys. Here I need confirmation, guys. JPMC guys, please respond. You guys are in here. Please respond if you have understood this question, or if I want you guys to repeat this. Guys, if you are not responding, how can I go further? Have you guys got this? Yes, no, Heli. Any doubts in this? Okay, clear. Thank you. So next we have breakdown in dielectrics. Okay, this is the last concept of capacitors. So yeah, so in insulators, I had explained about insulators in the beginning only. We had talked about this breakdown in initial case only, but yeah, I have to teach this again. So what's happening inside the capacitor or inside the dielectric medium? Say if I have any insulator, so dielectric medium is nothing but an insulator, right? Any insulator. So yes, so I have an insulator here. Now this insulator has very less number of electrons. Say I'll assume there are very less number of electrons or no electrons. So I'll assume the case of very less number of electrons in the valence band. Now what is the energy gap? I hope guys you remember energy gap from your chemistry. I hope you remember the energy gap concept from your chemistry. In your 11th standard you learned about energy gap. Yes. Yeah. So what is the energy gap between the conduction band and valence band? So in my previous class I had discussed about what is a valence band, how a conduction band, how conduction happens when electrons jumps from valence band to conduction band, how it happens, etc. So when we apply some potential, what happens? The electrons gains enough energy. The electrons gains enough energy to move from valence band to conduction band, and it moves from one atom to other atom. Okay, this is how it happens. But in case of in the insulator, there is a large gap. So this region is also called as the forbidden region. I hope this is known to you guys. So this was prerequisite from your 11th standard chemistry. Okay, so there is something called as forbidden region. Say if I apply enough potential, say about 20,000 volts, 20,000 volts, or something, just 3 electron volts. How much is 3 electron volts? 3 into 1.6 into 10 power minus 19 volts. If I apply this much amount of volt for any basic insulator, so is this very okay? 1 electron volt is 1.6 into 10 power minus 19 volts. So it should be 3 electron volts or 3. I think it should be 3 million electron volts. Okay, 3 million electron volts. So if I apply that amount of voltage, so 3 into 10 power 6 into 10 power minus 19 volts. At that very high potential, even my insulator will start to conduct. Okay, at very high potential, even my insulator will start to conduct. One example is lightning. So I hope most of you have seen lightning. Yes, it will start conduction. So how lightning occurs, guys? Help me understand how lightning occurs. How and why lightning occurs. So this was taught, the lightning was taught in the very beginning of electrostatics chapter, not initial classes in first chapter of 12th standard. So what happens? Yeah, when two clouds rub each other, there is large amount of negative charges stored in the bottom surface and positive charges stored in the top surface of the clouds. Okay, please listen. Chill. Okay, lightning ittalappa. So when I had lightning, so what happened? So I had two clouds. When they rubbed each other, what happened? So most of the negative charges were accumulated on the bottom region. All the positive charges were accumulated on the top region. So while lightning, you could see two types of lightning. One which is goes upwards, one lightning which comes downwards. I hope most of you might have seen, yes, angry of God. Okay, yeah, maybe. So lightning occurs this way. So what is happening when lightning strikes the earth, you guys? So lightning will be somewhere around, its voltage would be somewhere more than 36,000 million volts, million volts. Okay, this is the amount of 3,600 million volts. It will be very high voltage. Okay, so that will be very high magnitude voltage. So that voltage is enough to break the bonds. So what is my air made out of? Air is made out of moisture, water in air, nitrogen gas, oxygen gas, carbon dioxide gas. So it's made of several different gases in atmosphere, right? So when I give enough high voltage, high potential, what happens to these? These break, split into their respective ions. Say if I consider water, moisture is abundant in air. When I amount of potential is applied, this water will break into 2H plus and OH minus, right? If I'm not wrong. So H plus, okay, it should be like this: H plus plus OH minus ions. How? So all the moisture content present in the air would get ionized as H plus and OH minus. Now these ions can conduct electricity, right? I hope this is also studied in your chemistry. The ions conduct electricity. It's more like your salt water. Salt water dissociates into Na plus and Cl minus ions, right? Similar to that, my water content or moisture content present in air, because of the high lighting strikes, what happens? It splits into H plus and OH minus, and there is an ionized region. So forms ionized region. This is also called as plasma. So it forms an ionized region called as plasma. This plasma starts to conduct. Okay. This ionization in any dielectric medium, not only water, this ionization is called as the dielectric breakdown. Okay, so the energy gap between the dielectric, or the energy gap between the conduction and the conduction band and valence band, is also called as the dielectric strength. How much it can hold or how much it can withstand the electric potential. ಎಷ್ಟು electric potential na adu ತಡ್ಕೋಬಹುದು, or how much it can stop. For how much electric potential it can control the amount of electrons flow from valence band to conduction band is your dielectric strength. So the minimum value of electric field which breaks the dielectric medium, so less than that, say I have the dielectric strength, so the minimum value of electric field which causes the dielectric medium to ionize or conduct electricity, that amount of electric field we consider it as dielectric strength. Say if I require some 3 million volts to break air, so if I have 3 million volts between two conductors, so I have one conductor here and another conductor here connected across a battery. Okay, say this is connected across a battery. This battery, if it generates 3 into 10 power 6 volts, 3 million volts, then what happens? There will be a strike of air. I mean, there will be a spark generated between these two, creating a plasma region. Okay, this is called as the dielectric strength of air. So dielectric strength of air is 3 into 10 power 6 volts per meter. Not exactly, but yes, they say that. That's not yet proved, Pradeep. So, guys, dielectric strength is nothing but the minimum electric field required to break or cause the electric dielectric medium to ionize. Okay, hope this is understood. So, this is called as the dielectric strength, guys. So, dielectric breakdown is the minimum value of electric field which causes the dielectric medium to ionize or conduct electricity. So when I supply enough amount of potential, or when I apply enough amount of uh, potential difference, or if I supply enough amount of voltage to any dielectric medium, what happens? There will be rupture. So the dielectric medium will start to ionize and starts to conduct electricity. It won't be an insulator anymore at high voltage. So this part is called as the dielectric breakdown. Hope that is understood. So how is dielectric medium affecting the capacitance? So if when we are trying to increase the capacitance of a capacitor, okay. So if we are trying to increase the capacitance of a capacitor by reducing the distance between the plates. So how can we introduce the capacitance, guys? We can increase the capacitance by either increasing the area, decreasing the distance, or introducing a dielectric medium. Yes, it is possible, Pradeep. It is really possible to make all objects as plasma, but we should have enough amount of energy. Okay, so yeah, coming back, the capacitance of a capacitor, we can increase the capacitance of capacitor by increasing the area, by introducing a dielectric medium, or by decreasing the distance between the plates. Okay, so capacitance can be increased in these three ways. Now, if I consider this way, say if I consider the capacitance of capacitor is increased by decreasing the distance between the plates, my capacitance increases. Now we know that E dot D is equals to V, right? We know the relation between electric field and potential as E dot D is equals to V, or E is equals to V by D. Here, we know E is equals to V by D. If the distance between the plates reduces, what happens to the electric field? Yes, right. My electric field increases if the distance between the two plates is reduced. If D reduces, then my electric field will increase. Since my electric field increases, since my electric field increases and my dielectric medium thickness decreases, what happens to the dielectric strength? Hmm? What happens to the dielectric strength? Yes, the dielectric strength reduces. So if my dielectric strength reduces, then say if the applied electric field between the plates at some point would be equal to that of the minimum electric field or the dielectric strength, then the dielectric breakdown occurs inside the capacitor and my capacitor will behave as a conductor. will behave as a short circuit. So that is called as the rupture of capacitor or destruction of capacitor. The capacitor gets destroyed. Okay, so this is the dielectric breakdown, and the only expression you have to remember is dielectric strength is equals to minimum electric field, minimum electric field required to break the dielectric medium. Okay, so this is much of your capacitance, guys. So this is much of your capacitance. So this is end of your chapter. We have okay, if you have any doubts, please let me know in any of these concepts so far, in whatever the concepts we discussed today. Yes. So next we have some problems to solve. So dielectric breaks because, see, as I explained earlier in this case, so what happens when I apply enough electric potential? So Hari Prasad, listen. So when I apply enough electric potential, what will happen? These electrons, so when I apply some potential now, these electrons will gain some energy. When I supply some electrical energy, these electrons will gain some energy. Now these electrons will gain enough energy to just go and ionize this region. To ionize means to make them as dipoles. So there is this forbidden energy gap, right? So if I apply enough energy to this forbidden energy gap, what happens? This forbidden energy gap also will start to form dipoles, or similar to that of dipoles. Okay, what happens if it will try to break into its respective ions, positive and negative ions? It will also start to form positive and negative ions. Now, if this positive and negative ions formation is done, then what happens? My electron exchange happens easily between the valence band and conduction band. Thus, we can the energy gap reduces. Hence, the insulator also becomes a conductor. Yes, of course. If dielectric conducts, that's the breakage of dielectric medium. Okay, guys. So I hope that's done. So I have some questions for you guys. Please try to solve this question. Okay, we have few questions to solve. Okay, I have few questions for you guys. Please solve these questions. I'll be sharing them in today's class again. So once, so I have some 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So I have selected few questions which are very important for you guys. Please take some time today, solve this. Yes, exactly, Bhargav. Yeah, it takes. So those capacitor blasts are not from these dielectric breakdown, Bhargav. Those capacitors which explode are polarized capacitors. As I said before, they will be having some acid content within them. So the acid, so how a polarized capacitor is formed is, say they will take two plates of a capacitor and they will take a cotton swab. So they'll take a cotton. So this cotton will be dipped in an H2SO4 solution. Okay, this is cotton dipped in H2SO4 solution. Now, one conductor they will connect to positive and other conductor they will connect to negative. So what happens? This H2SO4 on conduction of current, it will form oxygen bubbles. Okay, it will form some oxygen bubbles here, pure oxygen bubbles on the positive surface. On negative surface, it won't form anything. On positive surface it forms oxygen bubbles. Now they will remove this and they will name this is positive, this is negative. Everyone whoever is using this type of capacitor should always connect this to positive, this to negative. This is a polarized capacitor, right? So this will be a polarized capacitor. Now what happens, sometimes some people may connect this ulta. So they may connect this to positive, this to negative. To certain extent this is correct. To certain extent this will withstand. So oxygen formation starts to happen even in this side also. Now if the potential increases further, what happens? There can't be storage of electric field, there can't be storage of anything. this formation of oxygen layer and some reaction happens between the chemicals, and this will just puff up. So you might have seen the capacitor gets bulged. Okay, then it will explode. It's exactly, Priyanka, correct answer. So guys, I hope many of you try to solve this. So the C nu, this answer is epsilon naught A by D times of, you could write this answer directly. So since these capacitors are connected in parallel, just add them, K1 plus K2 plus K3. So to solve these problems is very easy, guys. So to solve these problems, it's very easy. So you could just directly solve as, say you see, no easy direct. If you can see this, these three are of same area of cross section, but different. Sorry, same area of cross section of say A by 3, A by 3, A by 3. I think all three are of A by 3. Then this is K1, this is K2, and this is K3. Now if you connect all three, we'll get as 3K1 by 3. So 3K1 or 3K plus 3. So on solving, you will get the new capacitance as epsilon naught A by D, that is the initial capacitance, into K1 plus K2 plus K3. So this should be your answer. Yes, guys. Similarly, try to solve. Actually, there will be a factor of 3 divided, since this is A by 3. Okay. Please make that correction, Priyanka. So this as an area of A by 3. Okay. So your final answer will also be having an answer of epsilon naught A by 3 by D. Okay. They are not connected in series, Hari Prasad. See, I'm trying to write the same image in this form. So this much is K1, this is K2, then this is K3. So their equivalent capacitance would be C1, C2, and C3 with K1, K2, and K3 as dielectric mediums. Now these three are connected across the same potential A and B. Now each have an area of A by 3, right? Each have an area of A by 3, but same distance. So what happens to the capacitance? So my C effective will be equals to C1 plus C2 plus C3. So C effective will be epsilon naught A by D, A by 3 into D times of K1 plus epsilon naught A by 3 times of D K2 plus epsilon naught A by 3 by D times of K3. From here, I'll take epsilon naught A by 3 as common. So as common into K1 plus K2 plus K3. So this will be our first answer. Hope everyone have got this first answer. Yes. I hope most of you have got this answer. Second question, guys. So please try to solve this. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. Guys here, please, I hope everyone is following. Please try to answer this. Students in Zoom, please respond. Please try to answer this question. I hope first question you have understood. Let's try to answer the second question. First question, Artha Gita. Please let me know if you have any doubts here. So each capacitance has a distance of A by, area of A by 3 but same cross section distance. Sorry, cross section area is a by 3 and same distance, same width. So this was A and this was A and this was B connected to positive and negative. Okay. So, second question, guys. Yes, exactly. Krish Modi, correct. Krish Modi, correct answer. Others, please try to answer. Yes, correct, Pradeep. Answer is correct. Others, please try to respond. Say a parallel plate capacitor. So the question goes like this: a parallel plate capacitor between the plates has a capacitance of 8 picofarads. Say I had a parallel plate. Okay, I'll change the ink. I think it's not visible to everyone. So I had a parallel plate capacitor with capacitance of 8 picofarad. Okay. So 1 picofarad they had given. 1 picofarad is 10 power minus 12 farads, which you guys already know. What will the capacitance of a capacitor if the distance between the plates is reduced by half and the space between them is filled with a substance of dielectric constant 6? So what's happening? We know the capacitance C is equals to epsilon naught A by D, right? Now, if D is reduced to D by 2, then what will happen to capacitance? C nu will be, or C1, I'll call this as C0. With reduced D, I'll call it as uh, C1. So if C1 is equals to epsilon naught A by D by 2, this can be written as 2 into epsilon naught A by D, right? So then I'll get C1 as 2 8 is 16, 16 picofarad. Is it right? Can I write this way? Yes. Now, yes, since okay, this was D, this is first case. In my second case, the D reduced to D by 2. Okay. I had capacitance as 16 picofarad. That's correct, Tejas. Now, in third case, what's happening? I'm introducing a dielectric medium. So this is D by 2, this is A again. So I have introduced a dielectric medium of dielectric constant. So, okay, I will introduce a dielectric medium of dielectric constant 6. So what happens to the capacitance? C nu will be equals to, yes, 6 times of C1. So what will be my C nu value? 6 into 16, that is 96 picofarads. So option C is the right answer. Okay. So yeah, hope this is understood. Guys, next question, guys. If you have got that, please try to solve this question. Try to solve this question. So if the capacitance of the given system, so I have a capacitance of a given system with area, with each rectangular with an area A and plate separation is D. So this area is A. So this area is A and the plate separation is D. Now it is filled with a dielectric medium. So first half. So this is divided into 4 parts. Okay, guys, please listen. Now this is divided into 4 parts. So first 1/4 of the part or first half of the part is filled with one capacitor. So this type capacitance. When I filled this, its capacitance was 2C. When I filled a vertical line dielectric medium, the capacitance was 3C. And when nothing was filled, it was C. Now, if I have a new system, first quarter is filled with dielectric medium of type 2, and third half quarter is filled with dielectric type C, 3. Then fourth quarter is filled with again dielectric type 2, and second quarter is filled with nothing. What is the net capacitance of this medium? So this is very interesting question, guys. Please try to solve this. Take these questions as homework. So this question and these 3-4 questions as homework. So we'll start with these questions tomorrow, and this is end of your capacitance, guys. So we will be having test on Sunday. So we'll be discussing more questions on capacitors and resistor circuit. So from tomorrow onwards, we'll be starting with current electricity, guys. Please remember, from tomorrow onwards, we'll be starting with current electricity. And one thing to notice, one thing to say is, don't know whether your classes. So most of you are having tests, right? Jen, Mysore students, are you having tests? So Mysore students, are you having test this week? Okay, no test for Mysore students. Haveri students, do you have test? Priyanka, is your answer for this question, which is being displayed currently with 4 dielectric mediums? Hariprasad, is your answer for this question? Third question. Krish Modi, okay. All of no Madhavi, no Priyanka, no Hariprasad, no Krish Modi. No Krish Modi, check your answer. Okay. So guys, Haveri students, do you have test? I'm asking Haveri students, please reply. Vinayak, Chetan, reply Madi. Test is nimge ee week. Yes, Tejas, correct answer. Tejas, right answer. Shivraj, no, check your answer. Okay, YouTubers, okay, cool guys. So I don't know, but please attend the class. In spite if you have test, it's fine. But please attend the class. Tomorrow I'm going to start a new chapter, that is current electricity. Please be attentive. So please come prepared to the class. Okay, guys, please come prepared to the class. Tomorrow we'll be starting with the new chapter. Okay. Bhargav correct, Shivraj correct, Priyanka correct. Yes, A is the right answer for this question. Okay, guys, so I have to end the meeting. So we'll meet again on tomorrow's class. Till then, bye bye. Notes will be shared in Drive, Rakesh. You have a notes drive link in your WhatsApp group, right? So it will be shared in the WhatsApp group. Notes will be shared in that link drive.